Devlog 6. It's been a while since my previous devlog. My original plan was to integrate UI, prefabs, and particles as the new features into my game engine, and I thought this would be pretty straightforward. However, when it came time to implement these features, a lot of architectural vulnerabilities got exposed. And in order to fix that, it took almost 4 months of development time to be able to produce a demo for this devlog using my game engine. So now, let's take a look at what was done during this time. First, I rendered everything into a viewport. Along with it, I separated the editor rendering and runtime rendering, with editor rendering happening inside the viewport and runtime rendering takes the full screen to simulate actual final build perspective of the game. Then I implemented renderer version 2, which uses render queues to separate different types of rendering. Currently, I have divided it into 4 render queues, namely background, line, opaque, transparent, and then UI on top. For transparent render queue, alpha sorting was implemented, which basically allows the engine to render the scene correctly behind a transparent object. In the demo, the particle system uses it. This version of renderer allowed me to implement many different types of shaders such as diffuse transparent, diffuse alpha cutoff, unlit additive, and many others that were needed for the demo. Then I implemented a proper scene switching mechanism which separates the editor and runtime scenes. Before this, I was just using the editor scene, and when the user pressed play button, I started the simulation, and when the user pressed exit button, I resetted everything back to its original state as before the start of the simulation. And in order to achieve that, I had to manually do that in code in a reset function which accompanied every component, which just added more manual labor and it opened up a room for a lot of weird bugs. But now, with the new mechanism, a completely new runtime scene gets duplicated from the editor scene when the user presses play button, and the simulation runs on the runtime scene while the editor scene is deactivated, and when exit button is pressed, the runtime scene gets deleted and we return back to the editor scene. This auto fixed a ton of potential bugs, and also it opens up room for loading multiple scenes during runtime feature. Next up, I wanted to improve the scripting experience. Now my goal is to have C++ native scripting support in my engine, and I don't want the development overhead of another scripting language that I have to maintain and support long term in my engine. But the C++ native scripting experience is not that great. It's way too verbose and it slows you down productivity wise. So I had to figure out what I can do to make it better. Here's how my previous scripts looked like. I had to create a header file, a CPP file, and then implement all this boilerplate code till I reached the following function where I implemented the logic. As you can see, it's quite extensive and a waste of time. And also don't forget it uses many virtual functions, which means performance overhead. So taking all these points into consideration, I implemented native C++ scripting version 2. Here, every script being used is inside of this main function. I first declare all the variables that I need for the script, and then through function pointers, I implement the logic in the respective event which is hooked in the engine, removing the need for any CPP or header files. This is what any other scripting language such as C#, Lua, or high level language provides by default. And this can also be achieved with C++ through this approach. This feature made my life way easier and brought the excitement into my engine development journey, even though this is still version 2 and it has some issues. However, with version 3, I already know what improvements I need, which will further simplify it down the road. Next up, I added universally unique identifiers to all my entities in the ECS framework, which is pretty standard, but now it was needed, especially when implementing the prefab feature. There are many reasons for UUIDs, but one reason was to connect transform hierarchies correctly when loading a scene file or a prefab. With prefabs, I can create a custom configured entity layout with its own hierarchy, click on the Save as Prefab button, and it saves into the prefabs folder automatically on disk, and then later drag and drop it into the scene as many times as I need. It significantly simplifies editing of complex scenes or loading complex entity hierarchies at runtime. The prefab feature is quite extensive in actual use case, however, it is at version 1 in my engine. Next feature that I worked on was Model Editor version 2. In this version, I can have multiple models in a single renderer component which can be combined to optimize. And I can use any procedural shape from this dropdown and create a prototype layout for the model and apply a material to it. I can also transform the model metrics in the same way as I do with the entity transforms, which further helps setting up the layout of the model using these primitive shapes. I wanted to keep this feature simple as it has several purposes. One of which is to help create a model format that the engine can read and load 3D models from. So what it means is that it takes an FBX file and converts that into the engine's proprietary format and then load that into the scene. Also, this feature allows us to prototype quickly the layout of levels without going to another software right here in the engine. One more thing that I did with this feature is that I made the grid shape useful. Now I can apply a height map and it will create a simple terrain. This is not a separate terrain entity, just a simple shape that can quickly create terrains for testing purposes. I will, however, later implement a separate terrain entity which will be separate from this model editor. But this is another one of those features that helps with the level design layout. Lastly, I prototyped the UI framework, but unfortunately couldn't get time to properly integrate it into the engine. As 4 months is quite a long time, and towards the end of this Devlog's development cycle, I was literally dragging on to complete the work and get done with the demo because every new feature introduced its own set of bugs, which took more development time to fix those. So I had to make some compromises as I was getting burnt out. For this devlog, I just quickly used the prototype UI to show the frame rate indicator at the top left of the screen. However, this feature will get worked on for the future devlog. So now it's time for the demo, putting everything together. During the demo, I will stay silent and a text below would indicate what's being shown. As you can see, In this demo, everything is built using Model Editor version 2. There are no 3D models loaded from external files. The terrain is a square kilometer with quarter of a kilometer as the resolution of height map. The trees are two perpendicular quads and they use the diffuse alpha cutoff shader. This demo also shows the background ambience, which is controlled by three different positional audios, giving atmosphere to the environment. It also shows the particle system, collision physics, raycast, hit detection, and everything is controlled by the native C++ scripting system version 2, which handles all these complex interactions seamlessly. Now, moving forward, the roadmap ahead is that I'm going to focus on only one new feature for the next Devlog, which is going to be loading 3D models from FBX files. The rest of the work is going to be focused on fixing bugs, bringing stability to the engine across the board. As in the past 4 months, I added many new features in the engine which brought a lot of instability, and I had to work through critical bugs to get this demo ready and leave the minor issues in the process. And there are a lot of unfinished features that didn't make it to this devlog as well, but are in a prototype state, such as UI, post-processing effect shader stack system, which is what image effects are in Unity, better level design tooling features such as selecting entities through mouse click, undo redo system, better asset browser with more actions, and many more. I will try my best to get this all done in a much shorter time span because 4 months is a very long time and it's not healthy. However, I'm still in a very early stage of the project, so I have to balance things out at the same time. So that will be it for this day vlog. See you in the next one. Thank you.